Alright guys, so I'm going to kind of do like a CAD walkthrough on how to design a chassis that's buildable. So I've got Inventor 2020 opened here, and the first thing I'm going to do is make a part. Now in this first part of the series, I'm just going to make the drive rail. Nice and simple, kind of probably make up a few dimensions, but the idea is there. First thing we're going to do is make the profile of the here, actually, let me go back. Let me explain that better. We're going to start a 2D sketch, and this is going to put us in 2D mode where we can draw out what it is we're wanting to build. Now I'm going to start with the simple tube that we make our drive rails out of. So that's going to start with a rectangle, right, because the tube is a rectangle. And the dimensions of that are 1 inch by 2 inches. Now, to get to the other dimension, you can move your mouse and click on it, but what I like to do is hit Tab, and then that's just a little shortcut to go 1 by 2. Click Enter. Now I've got that rectangle there. I can finish this 2D sketch because that's all the 2D features I need to make this tube. I can then extrude this to be 28 inches. Sure. That's about the right length for a drive rail, depending on the robot. And then we'll come in and we'll turn it into a tube because right now it's just a solid bar, but we want a tube. So we're going to use the shell feature, and then what this does is it's going to hollow the whole thing out. And I could click OK now, and it would be a hollow tube, or a hollow body with a 0.1 inch wall all the way around. But I want a couple of open faces, and so what this allows you to do, as you can see, it's got remove faces selected, and I can click that face, and then edge over here, and click that face, and now I've got an open tube. And I'm going to change my thickness to 1/8 of an inch, 0.125 inches. And that's the size tube we're going to use to make this chassis. Click OK, and that's all good. Then I'm going to start another sketch, and I'm going to select the side of this tube so I can do some holes and some features. What we're going to do is we're going to come and we're going to place 3 points, because it's going to be a 6-wheel chassis, so I need 3 points on the actual tube stock. And then we know if we want to get this centered, so what I like to do is just, I know it's 28, I can do 28 divided by 2, and I don't know if y'all saw that, but I just grabbed the dimension tool up here, and I click the point, and I click the edge. Pretty simple, right? So 28 divided by 2, as we know, that gives us 14, and then, like I said, I can grab the dimension tool. You don't have to grab it every time, I'm just doing that to show you. And edge, point, here. Now, center of the tube would be 1 inch, but on these 6-wheel drive chassis, it's kind of common practice to run a little bit of a drop center, meaning that the middle wheel's a little bit lower and you get a little bit of rock. That reduces some turn scrub, which is the amount of friction there is involved in turning. So we're just going to do 1.1 from the top on that. This one will come down and we'll do 1 inch. Yeah, we can do 1 inch. And then we can dimension from the side here. If it's a 6-inch wheel, then we need at least 3 inches from the edge, right? Because we don't want any interference issues. We want the wheel to be completely contained. So I'm going to say 3.5. Give us a ½ inch clearance there. None of these numbers are hard set. This is just kind of a tutorial of the steps. It's, of course, up to you when you're designing a chassis, like what exactly it is you're wanting to do. I usually like 8-wheel drive chassis, but that's just me. Once we have those points laid out, we can finish that sketch, and then we can go up here and we can use the hole feature. So all we have to do is click on that. It automatically selects the points we put in the 2D sketch, and then you want to make sure there's a few things here. Termination, through all, direction. Yeah, that doesn't really matter for us. And then right here, we want our dimension, it's already there, but we want it to be 1.125 because that is the size of a bearing, right? Depending on your machining process, you might want to size these out a little bit and be like 1.127. I'm sticking with 1.125. That's what I like to do in CAD. I regret it sometimes when I get undersized holes back from manufacturers, but that's how it goes. And so, yeah, that's your basic drive rail. Pretty simple. Thank you. I'll see you in the next part.